I hope everyone had a great lunch. I know it is tough coming back from a high-carb endeavor and jumping back into technology, but what I have to talk to you about today, I am so excited about because I wanted someone to bring me this breakthrough when I was still serving in the US government, and it just didn't happen. And so after leaving, I started thinking, you know, if you don't do it yourself, you've got no one but yourself to blame. And so I start with a quote from The Matrix, one of my favorite sci-fi movies, and I completely agree with Morpheus. There's a lot that's wrong with our world, but there's something particularly wrong with the way that we are building systems in aerospace and defense. And what I want to share with you today is the problem that we face every day. You know it, but occasionally it's good to push back and not just see it in the here and now, but see it in the arc of history. So I want to take you on a historical journey. I also want to bring you forward to what has me excited, that the future of aerospace is not just going to be bright, but brighter than it's ever been, and restore this industry to the throne of innovation industry-wide. If that's not enough to get you excited for the talk, it's the best I've got. So buckle up and let's go into the problem. Now, this statistic is just damning. And all of the students that I just saw sitting out in the lounge that are at universities across the US and across the world that are enchanted by this industry, by aerospace and defense, and the romance of flying things and orbiting things and missiles that move super fast. It is romantic. But the second that you come in to our offices, you get thrust with this challenge that we haven't joined the rest of the software world. We force engineers and managers and everyone to spend nearly a third of their time just being certain that what they're working in on that day is the actual source of truth, the latest and greatest, decision-worthy, accurate, before they begin what they went to school for, which is applying their knowledge to build the future, to build great things. This is the problem we want to tackle. This number should be zero. There should be zero time spent trying to figure out, are you working in a source of truth? There should be zero time spent trying to wonder, is this the correct version controlling? The world of software tells us this, but it's been denied us. If you've thought that at any point in your aerospace journey, then this talk is for you. We are going to go on an arc of history that ends with finally bringing the world of software into the world of hardware, and then we'll speculate about what's to come. But before we jump in, let me give a big shout out to AIAA, especially the DEIC team, the digital engineering team, that have really embraced and have done a lot of hard work to enable this talk, including the demonstration that I'm going to show you at the end. So let's get in the Wayback Machine and go on a little bit of a journey through history. If you think about the things that have changed the world, ideas, politics, war, nothing has been as powerful as infrastructure. It doesn't get a lot of the limelight, but if you look at the changes in how we live and how we conduct business, everything centers around infrastructure breakthroughs. Let's go back to ancient days. Before aqueducts existed, civilization was limited in size just by water alone. If you want to build a city and you outstrip your water supply, you're in trouble, and that's the best case scenario. Rome broke free of the tyranny of having to have natural resources co-located with cities by building aqueducts wherever their cities were. In Rome alone, there were 11 bringing in 200 million gallons of water every day, and many of them still work today. There were fountains on many street corners and baths. This changed how big cities could become and really set up their next infrastructure breakthrough, which are road systems that span their empire. 50,000 miles of them, many of which are as good today as if they had been freshly built. It's an amazing engineering accomplishment, and arguably what let them control their empire just as much as their legions. Now, we could go down the history lesson, but let's back up and ask ourselves, what did they get right? There's a lot that Rome got wrong, but they got something right about infrastructure. And that's that it created a level playing field. And that's not always good. It could be for collaborating, it could be for competing. Certainly bad things happened because of enabling infrastructure. But the idea is the road was for everyone. The aqueduct was for everyone. It didn't own the cargo that was moving on it. It didn't own the water that was moving on it. It enabled them. It allowed civilizations to grow. Now that's the pattern. That's what we want to see on this journey. Now let's fast forward to the industrial era, to the railroad. Now, the railroad was far more than just a better road system. It really changed how large and how broad businesses could grow. Before the railroad, sending your goods abroad, unless you had ports and ships, was too costly to even consider. When the railroad came out, you could move 10 times the payload, 10 times the speed for 1/10 of the cost. Business models became possible that simply weren't before. What also came into bear were standardizations. 4 feet 8.5 inches was the standard rail gauge. If you didn't build your railroad to that spec, your business was not long in the world. Standards started becoming a form of soft power. The reason we had that in the US is that it started in the UK. This let businesses start expanding their reach. And when the telegraph came out, for the very first time in human history, people did not have to come together to share information. Magically could be shared at a speed never foreseen. Businesses weren't just reaching globally, they could make decisions at a range that simply was not feasible before. Now, in the industrial era, this playing field is now reaching nationally, coast to coast. But what it still got was that it was level. The railroads didn't own the cargo that moved on them. The telegraph didn't own the message. Of course, there were fees to use these things, but these were known. These were transparent to those who took place with them, and it allowed innovation to spread to areas that previously weren't possible. As we come forward to the 20th century with electricity, that innovation continued to expand. Factories were no longer shackled to waterways or area where natural power could be tapped. Innovation could spread anywhere, and factories weren't limited to artisanship, small production lots. They could start producing for the world. And in the 1950s, I can't remember if it was 56 or 58, but when Malcolm McLean invented the shipping container, it went global. Before this, it's hard to imagine today, but before this, it took days to weeks to load a ship and then to unload it on the other side. The standard shipping container came out and it dropped to hours. Now, nearly everything that we own has been in one, global in scale. At this phase in history, the level playing field is still intact. Globalization happened and lots of bad came from that. But the rules were understood. Not everyone had the same starting conditions. But the infrastructure was independent of the things it transported. It was a conduit, not a captive cage. The pattern, still intact. Let's move to the internet era. Before this era, broadcasting was highly regulated and highly controlled, and the broadcaster effectively had no ears, had no real feedback from the audience, and the listener had no voice. The internet came out, and a student in their dorm could now reach as many people as the New York Times. broke down the ability to reach not just nationally, but globally. And then when cloud came out, that same student wasn't just reaching their message to the world, they could create companies that could change the world. You no longer had to buy servers and computers to start going to market. You could swipe your credit card and off you go. With 13 engineers, Instagram was supporting 30 million users. With 55 engineers, WhatsApp was supporting 1 billion. Startups became possible at a scale never foreseen. They changed the world, and different business models came out. The as-a-service model emerged, companies that were giving away capabilities because they could monetize data. And this is the part in history where the pattern starts changing. The digital playing field starts getting a little bit of a slope. And I'm not sure anyone noticed at the time, but now we do. We can sum it up in 2 words. I agree. We've all clicked it. Do you remember when it made you feel bad to do that? I do. Do you remember when you could actually read the scroll down list of the agreements? I do. But over time, we became accustomed as individuals that when we click this button, such amazing, empowering capabilities exist on the other side that we dare not do otherwise. And it's been a good bargain for most of us. Our personal data, what we're watching on Netflix, our posts are really not valuable on their own. Who would pay for them? But if we put them together, if companies do that, then in aggregate, statistically, they are powerful. They are the backbone of the analytics and now the AI that's changing the world. The internet has worked out fine for individuals on the whole. I certainly wouldn't want to go back to the era before this. But this doesn't work for enterprises. Enterprises can't click this button. Whether you're a company, whether you're a government, your data is valuable by itself. It's the crown jewels. It's what you use for competitive advantage. Giving it away is not happening. And so as the internet started connecting all of us in ways that never had happened before, enterprises were less isolating the danger of the internet all around them. And in aerospace, we experience this every day, acutely, in 3 particular problems that ate my lunch nearly every day running Air Force and Space Force acquisition. Our programs were plagued by these boundaries with no real way around them. First, we use a lot of different software tools to design aircraft, satellites, missiles, you name it. Aerospace is a broad enterprise. Within the US Air Force and Space Force alone, I was tracking 3,000 to 4,000 tools. It was hard to know exactly how many we needed to do our job, but it was a large number. Most of them weren't interoperable with each other. It was not like the internet. People were having to be the translators, sending emails and copies and versions to everyone that was collaborating, because whatever tool the collaborator used, it didn't work with theirs. That's problem 1. Now, problem 2 is a little more insidious. We're a bureaucracy in most of aerospace. In fact, most cyber-physical industries that are regulated are. Bureaucracy is often a pejorative. It's a good talking point for what's wrong with our system. But we have checks and balances for a reason. Bureaucracy, separation of power. Don't give everyone all the decision authority. Checks and balances make things safer. Well, checks and balances mean you have separate entities that have separate data. They have separate authority. Putting it all together on one IT system doesn't work. For someone, it's their home game. For everyone else, it's an away game. How could they possibly say that their data is being used appropriately, their authority being exercised appropriately? if they don't have control of their IT system. And so across the Air Force, every separate authority had their separate IT, their home game. Well, how did the home game happen? Everyone had to send them a copy of what they were working on. The latest, version 37, redacted for whatever they're allowed to have so that they could extract information out of it and make a decision. As I think about the entire Air Force and Space Force during my time there, almost no one was working in a source of truth, ever. Only the local expert that was doing the copying and pasting. Everyone else is in a copy. So bureaucracy, there's one path of saying it makes things slow, but logically it does. This copying of sources of truth is more than just human behavior. It is a problem that needs a technical solution. And that leads us to 3. If you've got checks and balances in different entities, you've got audits and oversight. There have to be paper trails. Air Force, Space Force, 24,000 decisions a year, each one a folder with stapled documents to it, explaining why the decision was made, what information it was based on. There was a copy of that information, who read it, who signed off on it, any edits that were made, so that if we were ever questioned about why we made a decision, we would pull that out, review and refresh ourselves, and that was our evidence. Copies in a folder, archived, paperwork. If you really step back from our world and compare it in the arc of history, we're the infrastructure, humans. We're the translators. We're the API. We're the transport layer using email and Dropbox and DoD Safe. And we are doomed to repeat this again and again every time something changes. And the reason we do it is there's no better way. It's amazing that it builds the amazing things that this industry does. So how do we fix it? You know we're headed here, right? We can't leave it this way, right? Especially in the era of AI, we'll be even further behind if we can't digitize. So how do we fix it? Well, we need an infrastructure that's built for aerospace, for every cyber-physical industry, not one that's built outside, that's thrust upon us, that doesn't consider our reality. And that infrastructure needs to work without humans as the interstitial layer for everything, between our tools, between different teams, between different authorities, and between the checks and balance of auditing process. Quite a lot to ask of this infrastructure. So we're going to build it one step at a time. Let's start with the easiest place, with our data. So where is it? Where is it in aerospace? It's not in one place. It's in thousands of places. In a major weapons system, few thousand suppliers that are working for an OEM, so a few thousand sources of truth. And then we add the US government, the requirements owners, and then the acquisition oversight, then the testing community. Everyone is a source of truth. So think of them as this data plane. They each have a tool that they're using, in the case of the Air Force, 3,000 or so. The first thing we're going to do to change the paradigm is not have the human as the translator. We're going to replace them with a software agent that is taking the data that's inside of their tool, that doesn't plug and play with everything else, and translating it into an open, vendor-neutral copy on the outside that speaks the language of interoperability. If you want to think of this in a historical context, back up to the telegraph, right? No matter what language you spoke, your message could be sent over the wire, could be universally translated thanks to Morse code. The language did not limit what you could communicate, nor did it own your message when you were done. It was simply a mechanism to allow something you wanted to share to be received in a way that it could be understood. If we add this to each one of our sources of truth, we've got the equivalent of a translation layer that does not need the human to do it for us. And why can't we have software do it? Especially in an era where AI is writing software better and more reliably, where humans can check than ever before. And it's not just an idea. We have partners who are doing amazing things with this. Boeing Australia is building the Ghost Bat, the MQ-28. And their idea is to turn their integrated digital environment externally, to not have it be something that's interfaced with by payload providers, many of whom are here this week, by emails to their engineering team, but be able to interface and ask questions like how much payload can you carry and voltage and 1,000 other things that people need to understand, and not just do it with a user interface, but to allow language models, natural language, to be an interface that anyone can use, to talk to their models, to talk directly to a source of truth. And when you think about like a GhostBat GPT, it's exactly what we need to cut through the tools defining rules about how collaboration works versus the tool being contributing to our language, but not contributing to a barrier to collaboration. I think this is the forebear of many more such GPT for physical systems. Don't learn the tool that's curating the source of truth. Don't learn the UI. Be able to talk to truth directly. So good on Boeing for blazing the trail. But data in isolation isn't enough. If we can talk directly to the data, something has to orchestrate the control of it. And that's typically where I saw my time in the Pentagon go wrong, is that you can protect data. You could imagine creating API endpoints for each. You could imagine what a microservice could look like. But every time it was attempted, the control plane, which is what's supposed to help you determine who gets access, what commands are authorized versus not, always got tainted by the data, including my attempts as well within the Air Force. And once your control mechanism is tainted by the data, something really bad happens, and it happens fast, is it inherits all of the sensitivity of the data. And within the Department of Defense, where you're dealing with classified data, you start rolling up into higher and higher levels of classification where eventually almost no one can interface with that data. In fact, after seeing how Formula One was building race cars, and I know they were here earlier this morning, still one of the most amazing industries I've ever been associated with. It was so clear that what let them move so much faster than us wasn't better models and simulations per se. It's that they were able to bring everything together, because from a supplier standpoint and an IP standpoint, they are a simpler industry. They didn't have this problem of a control plane rolling things up in classification to the point that it couldn't be used. The only programs that I had within the Air Force and Space Force that could copy were the most classified, where everything was aggregated together for national security. And then you could start attacking the integrated digital environment problem like Formula One with some hints of their success, ways to go, but you could see it if you could get everything together. So this control plane problem I consider to be one of the hardest to solve, and I think the team that I'm privileged to lead have done it. So let me walk you through at a high level how it works. So let's say you're the data plane owner on the right-hand side. You have these agents, they're working ambiently by your software tools. The expert is working inside of the tool. There's an open, interoperable, vendor-neutral copy on the outside. Great. You have a collaborator. You would like to grant them a one-time access to that data. You don't want to give them a copy. If you give them a copy, they're not in the source of truth anymore. You want to give them access to the truth. So how do you do that? Well, the first thing that you do is that, notice we're not in the language of the data planes. We're in a different color that we haven't described yet, we haven't defined. That's the trick. The trick is coming up. In a different language that is not sensitive, we would publish to a control plane, not our data, but A workflow that is authorized. User X user X is allowed to have data Y for purpose Z. This is authorized, published to a control plane, so that when a separate data plane makes that valid request, the control plane can authenticate this is user X, they are requesting data Y, and it is for purpose Z, so that when this is relayed to the original data plane in this language that is not sensitive at the data language, that the two data planes can interact via a one-time token, a one-time access, a one-time ticket, an API call to that data. If this were possible, we haven't tainted the control plane. The control plane knows a lot about workflows that are authorized, access that's authorized. It doesn't know anything about the data on the other end if we do this right. In the Defense Department, was never gotten right. This is the big breakthrough from the team that I lead. This is the trick. But before we get to the trick, let's talk about what some companies are doing with it, and first put it in the arc of history. So what we're really doing with that control plane is a routing function. We're just routing access to data, complicated data from complicated sources of truth. But what we want is the router to remain completely non-sensitive. So just like our internet routers, but with no data, just routing access. And it's not theory, this is what we're doing today with the Air Force Research Lab and with Lockheed Martin Skunk Works, blazing the trail, building the X-56A next plane, which will be the first attempt at a digital certification, no paper, being able to have sources of truth, work directly with sources of truth, no paper, no human APIs in between, so that everyone knows that decisions are being made in the latest and greatest information. If this succeeds, it's just bringing in the GitHub paradigm into our industry, but not a single hub, multiple hubs, breaking up the central repo into authoritative federated repos so that everyone is working directly in the latest and greatest. If this succeeds, it'll be the forebear of many such bringing software into hardware programs. So good on the Air Force Research Lab and Lockheed for blazing this trail ahead of aerospace. Expect more from this program this year. It's being physically built and will physically fly this year. We may talk about that some in the panel that's coming up. Now we need the trick. Sounds great. Okay, I've got data. It's being extracted out of my tools. I have a data foundation I own. It's machine interpretable. It's vendor neutral. Sounds like what I want. I like the idea of this control plane. I can hear myself saying in a former life, sounds good, but sounds like you need a very clever trick to have this language that's shared between them that doesn't taint everything and ruin what would otherwise be a good idea for decentralized infrastructure. This is the provenance plane. And to understand what it does, let's take one more trip back in history. So this is Hans-Peter Loom, who not a lot of folks know, but they should. He's really the creator of hashing functions back in the 1950s at IBM. That was a period where sorting data, searching data, knowing if data was correct or not was highly challenging. It's hard to imagine that today because almost everything we do rides atop of the technology that he helped trailblaze. But during his time, he had an idea. We don't know if a credit card number is correct, a telephone number is correct, but if we mathematically transform data and put it into a mathematical bucket, we can make it easier. And this idea caught on at IBM and really changed the internet that we have inherited today. This idea of transforming data into a more usable form. And cryptographic hashes have been used to help us make the internet more secure, but what everyone does is transform data into a unified space. Well, one of the very cool things about what grew up in the rest of the internet is that these hashing functions, which are helping you share data securely in the cryptographic case, they need to be generated decentrally. You don't want to have the central generator of these. That's not the way the internet works. You want to be able to transform data locally, send that transformed data to other people who can check things like, is it the same? Does it match? And so there was a need to ensure that the functions transform data into long enough strings of characters that no two would ever be the same. Even if you had hundreds of thousands of people generating them every day, the likelihood that two of them would collide would be near zero if you made the strings big enough. Well, a very cool byproduct of this idea in the era of AI is that if you give every piece of information a unique ID, locally generated, just like Loon's hash functions have grown up in the internet, that 36 characters gives you a 1 in 340 trillion probability that two will ever be the same. But in our era, the probability that AI would ever hallucinate one of these strings of characters is equally improbable. They're effectively an unspoofable, unforgeable ID that could be assigned to every piece of information, generated locally using algorithms that exist, so that every piece of information has its equivalent of a fingerprint. And importantly, a fingerprint that's not the same as anyone else's, unique, and never hallucinatable by AI. Now that trick sets us up to do what the control plane needed. We are not going to give the control plane information like user X wants data Y for task Z. That's sensitive information in many cases. We give the control plane the IDs, only the IDs. The IDs are locally generated. Who are they valuable to? Well, they're only valuable if you sit where the data is located. Outside, gobbledygook string characters that have no meaning unless you can bring them back to the data that they're tied to. It's a language that's safe to go between each data plane and control plane because absent being where sensitive information is, it isn't. And this year, the US Air Force will, working with us, show that this approach to data ID and data ID management doesn't just work for unclassified data, it can work across unclassified up to top secret information. And if we prove that, it finally brings down the classification barrier, which has been so penalizing in defense. Now, there's a lot more here, and thankfully, there are a lot of smart people from Istari here who are happy to take you deep. But it's this three-part story. Keep the data with its owner in a way that's machine interpretable, create a control plane that can route access to it that never gets tainted by the data, and create an ID language, a map of data that has no sensitivity outside of where the data is located. And you now have a way of decentralizing access to information, which the internet simply doesn't let us do with the security we require today. Now, the shout out here goes to Blue Origin that at AWS reInvent this year announced that they had built a space qualified moon battery using this infrastructure and their amazing investments in AI. What the AI did, designing something 75% faster and 40% better, is amazing. It makes me so excited about the future of this industry. But a really important footnote is that what made it qualifiable is that these ID systems, the provenance plane, was used to create guardrails for nearly everything that would keep you up at night in an enterprise. The laws, the regulations, the statutes, the requirements, the things that if you can't prove you pass them, then you don't get to do anything. What you built is a hunk of metal. Blue Origin used the IDs that can't be hallucinated to create guardrails so that if a design was created, it could be deterministically checked against the requirements, against best practices. And these guardrails make me really excited because former regulator, I could imagine making all of the worries, the things that stopped innovation dead in its track, unit tests that are just humming in the background so that every AI-generated innovation is compliant by design. And with the red tape out of the way and the lawyers satisfied and the security professionals at peace, finally, the focus can just be on innovation. So if you step back from this, we all know how cloud works. It's amazing. It's changed our life. I wouldn't go a day without it. Cloud is about sharing computers. Change the internet. Our data's together. We get access to analytics and AI we would never be able to run on our edge devices. But we don't get a shareable protocol layer. When your data is in the cloud, you are not in complete control of how it connects there or elsewhere. That's really the issue. What we've just described is really the 180. We didn't have any shared computer. In the architecture I showed you, the data plane was, well, it was everyone's computer, right? It was data where it would normally sit. And the control plane and the provenance plane are really just providing you a way of connecting it without consolidating it together. And with a little tongue-in-cheek, we joked about calling the infrastructure ground as the opposite of cloud, but it's not a joke anymore. It's a really good way to think about a complete 180. It's what we've been missing, and it makes sense that it should be the inverse. When you are not able to consolidate, still be able to connect and map your data. And so what this does is take that I agree banner that no enterprise can click, that no government can accept, and completely changes the architecture to an I grant architecture. Not once and for all, one at a time, with fine-grained controls forever. The owner of data gets the psychological safety net of knowing everything that happens to their data forever. Their collaborators get the psychological safety net of knowing the information they're accessing is always the latest and greatest source of truth. So, to review, we take an aerospace system. This is today. We're all consolidated together, and that's the problem. Most of this data isn't a source of truth. It's a copy of a copy of a copy sent in to someone who's integrating. We're leaving the data in whatever tool it's in, federated across the enterprise. We're extracting out the data artifacts, each one machine interpretable, each one with an API endpoint that can be called, and we're version controlling it across history. Oh yeah, and a byproduct is that all of the IDs that are being used to map this federated system can interface with AI without ever being susceptible to hallucination. It's a pretty good byproduct. But seeing it in a PowerPoint presentation is nice, hopefully tees up the idea, but I wanted to end by letting you see it work live. And James, who's a smarter guy than me on our team, is going to bring up a laptop, and then hopefully, if the demonstration gods are with us, then I'll show you this in practice, and then hope that this inspires you to think that our future, the future of our industry, isn't going to be shackled to paper anymore, and that finally the digital era is going to happen to us. So I'm seeing it here. There we go. So you could imagine that that airplane I'm showing you is not a picture, it's a real airplane. This is a tool called NTOP, which is an amazing tool for fluid geometries that we're going to talk about in the panel. We're actually using this tool to design this aircraft in the hackathon that we're doing today at 4:30. If you like the demo and you want to do it hands-on, we're going to put 100 people on the keyboard and let you improve this design. Brad's tool is like geometry becomes like water. It just flows. But an aircraft is more than just geometry. You need requirements, They're usually extensive. This is another cool tool called Syscit, which is capturing all the tree of what things need to be met and not met. And then maybe you've got some simulation results that have come out of, like, say, MATLAB that you've put into some Excel spreadsheet, Excel still being the most common digital engineering tool in my tally. All of this and many, many more systems are the aircraft. But on the Istari infrastructure, they're all together. You see them as one system. So I look down, I've got the wing design, I've got aerodeck metrics, I've got different baselines that have changed. And although this data is accessible to me, the copy of it isn't here. I just have been granted access. I'm seeing it live as a source of truth. If the owner decides I shouldn't have access and I try to recreate that design, I get this. I never had a copy of it. I had an API call. I was just denied. Nothing renders. And then as things change over time, these universally unique IDs that come from that provenance component are really important. Every artifact has one. It gives you an immutable way of tracking that digital entity, of turning the paper trail into a digital paper trail, and doing powerful things like differencing between two different systems so you can see what's the same and what's changed, things that I remember having to do with my eyeball in Air Force and Space Force contracts, checking to see what was the line in and line out. Now, this alone gets me really excited. This is what you will be able to play with in the hackathon. But you know, in today's world, AI doing everything, what we really expect is to be able to pull up a tool like Claude or any language model that you like using and ask a very detailed question, like getting a bunch of sources of truth about this aircraft and putting it into some mil standard component so that all of that drudgery work of opening and copying and pasting and emailing and redacting and version controlling, the humans as the infrastructure, all of that just becomes a natural language query with a language model. Now, this will take a couple of minutes, but at least when Air Force acquisition, this request would probably be 3 to 6 months to just get a simple document that's been approved. So 2 minutes is worth the wait. And as we wait and look ahead, what I'm so excited about is that the US Air Force has, just as of Friday, kicked off a program called Industry One, which is putting each one of these components, the localized data in a vendor-neutral format, a control plane that can be shared across industry, and a universal ID system that is not sensitive and safe to share, that's universally unique. They're putting them all together in one program called Industry One, that is going to try to take this term, level digital playing field, and not make it words in a PowerPoint presentation, but an approved position, an approved finding. So it's a big shout out to the Air Force for seeing the future, you know, ahead of the pack, and a big shout out to all the companies here who are participating. And I think what we're going to find is similar to using Google Docs or any of those collaborative tools online today, that whether or not we've got a copy of the information is going to quickly become something we don't even think about anymore. We're simply going to think about whether we have access to it or not. And just running Istari today, that's our day-to-day life. Most people do not have a copy of the information that they're interacting with, but everyone has access directly to the source of truth. And it's just amazing what language models are able to do when you give them well-curated data. You tell them where the sources of truth are, and then most importantly, when you ask the model to give you the model IDs for every single artifact so that you can independently check it in the source of truth. It's the model ID in this document that turns it from being just merely something that AI did for us into a decisionable document. And so what I love in the era of AI is that this infrastructure isn't coming in to try to give you a better AI solution. It's giving you a deterministic counterbalance. And if our AV friends in the back can take us to the slide deck, let's bring it home. I'll show you some more of us here. And it's just amazing. I mean, I never get tired of seeing this. Look, I mean, it's just being able to pull this from these myriad sources of truth, and they all are there. Oh, thanks, we're back. So we'll quit geeking on AI. If that's of interest to you, see me afterwards. We're happy to show you some other things you can query on the laptop. And come to the hackathon. Smart folks will tell you more about what they're seeing, future of AI native engineering. All right, let's bring the panel home. So some of you may know that, like, when I was working in the Air Force, I was trying to get through to all the team I was working with that what Formula One was doing was different and would be revolutionary. And I just couldn't get through. Whenever I would say digital engineering, everyone would say, hey, Will, we're using a computer for everything. We're there. But we weren't doing it like F1. And I so wanted us to attempt it. And so almost as a joke, I decided to write an official Air Force and Space Force document inspired by the Matrix, which is, of course, a digital reality that we live in the movie. Well, I wanted us to be able to live in one for airplanes and for satellites. And so I wrote this and had no idea whether it would matter or not, but I think just having something fresh and creative at least showed a workforce that I cared enough to do the writing. Well, in it, there are 3 different tenets that had to be met. 2 of them already had an enabling technology. We wanted to be able to move from our tech stack to our edge and everywhere in between seamlessly. Software containers were doing that for us. We wanted to be able to e-create before we aviate or shift to digital-first operations. You can pick your flavor. The whole idea was lean on digital sources of truth. F1 did. But there was one principle that we needed to be able to own our tech stack while sharing it. It sounded good. I knew what I thought I wanted, but there was no technical solution to do it. What I've just shown you, I think, checks that box. All barriers are out of the way. And if this is of interest to you, I haven't written a concluding chapter, but on the 26th, this will come out. And it will give you a lot of details there's not time for here, and hopefully some inspiration about what is to come. The future of this industry is no longer going to be behind paperwork and bureaucracy. We are finally going to get to join the modern internet, but not, as Neo articulates, a world without any rules or controls. A world without borders, without barriers, of infinite possibility, but where all of the rules and controls that every time we get together and discuss innovation always dominate the discussion when we go home and put all good ideas on the back burner. Finally, all of those are going to be running ambiently everywhere. And now there's no excuse not to innovate and pick up the pace.